lecture we will start unit 4 of big data. In unit 4 these are the topics that will be discussed: Hadoop 2 features, name node high availability, HDFS federation, MRV2 or yarn, introduction to NoSQL, MongoDB, Spark and Scala. So first topic is Hadoop 2 features, name node high availability. In Hadoop version 1 we have discussed in unit 2 that Hadoop 1 has one name node and a number of data nodes. So it creates a resource bottleneck because name node has to save all the metadata related to the small files or large files that are actually saved on data nodes. So if the name node crashes, then the whole system also crashes. So there is a need for name node high availability that comes with solution in Hadoop version 2. High availability was a new feature added to Hadoop to solve the single point of failure problem in older version of Hadoop. As the node HDFS follow the master-slave architecture where the name node is the master node and maintains the file system tree. So HDFS cannot be used without name node. Before Hadoop 2, the name node was a single point of failure in HDFS cluster. Each cluster has a single name node, and if name node falls, the cluster as a whole would be out of service. The cluster will be unavailable until the name node is started or brought on a separate machine. So Hadoop 2 overcomes this single point of failure by providing support for many name node. HDFS name node high availability architecture provides the option of running two redundant name node in the same cluster in an active passive configuration with a hot standby. Means only one name node will be reside in the active phase and other name nodes will be in the passive phase. Name node high availability. These are the one. It handles the client operation in the cluster, and passive name node, it is a standby name node which has similar data as active name node. It acts as a slave, maintain enough state to provide a faster failover if necessary. If active name node fails, then passive name node take all the responsibility of the active name node and cluster continues to work. HDFS federation. HDFS federation means HDFS 2 architecture. HDFS 1 we have discussed in the Hadoop 1. HDFS 2 or HDFS federation means the HDFS architecture available in Hadoop version 2. HDFS architecture, this is the architecture we have studied in Hadoop 1. So we are comparing HDFS 1 architecture with the HDFS federation architecture. In the HDFS 1, name node is there, a single name node is there, and a block storage is for data node, storage layer is there. So namespace consists of file blocks as we already discussed in HDFS architecture, and directories. This layer provides support for namespace related file system operations like create, delete, modify and list of files. Block storage layer, it contains block management plus storage. So a single name node is there. In HDFS federation, feature introduced in Hadoop 2 enhances the existing HDFS architecture. It overcomes HDFS architecture limitation by adding multiple name node or namespaces support to HDFS. The HDFS name node contains two fields. One is namespace and edit log. Namespace contains the every detail of files, read and write operations, modify, delete, all the operation happening on the files is saved on the namespace. And edit log contains the information of the transaction held on the data. So in HDFS one name node is there and one namespace is there. So this allows us to use more than one name node or namespace. Means one name node is associated with one name node in HDFS1, but in HDFS2, HDFS Federation architecture, and more than one name node is there, so there the namespace also associated with the a number of name nodes. Therefore, it scales the namespace horizontally by allowing the addition of name node in the cluster. This is the HDFS Federation architecture, or you can say HDFS2 architecture. There are NN1 is for name node 1, name node 2, name node n till name node n, and each name node is having its personal namespace NS1, NSK, NSN, and this each namespace is having block pools, pool 1, pool K, pool n, but then all the block of pools shared a common storage of block storage, and the original block of data saved on the data node, as we already discussed. So HDFS Federation architecture, these are the key points or the features of HDFS Federation. There are multiple name nodes which are represented as NN1, NN2, NN1. The multiple namespace by their respective name node. Each namespace has its own block pools. Each data node stores block pool of all block pools in the cluster. For example, data node 1 stores the block pool from pool 1, pool 2, pool 3, pool n. Means there is a common storage of data node block pool. All the block pool 1, block pool 2, block pool n will be stored in data node 1, and all the pools are sharing the data nodes. Summary: HDFS Federation added to Hadoop to provide support for multiple name node or namespaces. This overcome this is the important feature, or you can say that this is the advantage of HDFS Federation over HDFS1 architecture. This overcomes the isolation, scalability, and performance limitation of the prior HDFS architecture. Next topic is MRV2. MRV2 means Map Reduce version 2. In unit 2, we have discussed Map Reduce version 1. Now Map Reduce, what are the disadvantages in Map Reduce version 1? Map Reduce version 1 uses the job tracker to create and assign tasks to data nodes, which can become a resource bottleneck when clusters scale out far enough, usually around 4000 nodes. Means in MRV1 or MapReduce version 1, there is a job tracker which handles the work of job assignment, task execution, task progress status. All the work is done by only job tracker only. But in MRV2, it has a resource manager for each cluster, and each data node runs as a node manager. Yarn overcame the scalability shortcoming by splitting the responsibility of job tracker into separate entities. The job tracker takes care of both job scheduling and task progress monitoring in MapReduce version 1. But in MapReduce version 2, also called YARN, separates these two roles into two independent elements, a resource manager and an application master. Resource manager is fixed and static. It performs node management for free and busy nodes for allocating the resource for map and reduce phases, while application manager communicates with the resource manager. The rest topic of MRV2, the rest matter of MRV2 will be continued in next slide.